Hello everyone, I welcome you all to this video of the continuation video of the geometry concept 4 video, wherein we will be discussing few more concepts of the geometry area. In the previous 3 videos we have seen particularly the concepts pertaining to triangles, and the questions were entirely triangles based, right. So we have looked at a few concepts in those questions. In today's video we shall be taking up quadrilaterals, right. So quadrilaterals again will not be getting to details of all the properties that we have for quadrilaterals. So I will just be limiting myself to the type of quadrilateral that we are presented here for question. So for example, I have 2 questions today. One is from the trapezium, other is from the parallelogram. So I will be trying to discuss the properties pertaining to the trapezium and the parallelogram. Let us start with the trapezium first. So quadrilateral is basically a polygon which consists of 4 sides. Right. So quadrilateral, general quadrilateral can look like this, right. So quadrilateral ABCD. So one of the properties that we have for a quadrilateral is sum of interior angles in a quadrilateral is 360 degree for any type of quadrilateral that you take. Also sum of exterior angles is also 360. So that means quadrilateral is one kind of unique polygon wherein sum of interior angles is going to be equal to sum of exterior angles. For no other polygon this holds true, only in case of quadrilateral it holds true. Sum of interior angles is equal to sum of exterior angles. Now one more thing that we have in polygons in quadrilaterals for the first time is something we call as diagonals. So diagonals are basically the line segments which join non-adjacent vertices. So A with C, B with D. These are the 2 diagonals that we see, right. Now depending on how the sides are placed, how are the angles in a polygon in this quadrilateral, there are different types of quadrilaterals that we come across. One of the types of quadrilateral is, I will just clean this, we call it as a trapezium. So this was a general quadrilateral, now a particular quadrilateral we call it as trapezium. So what do we mean by trapezium is basically in a quadrilateral when one pair of opposite sides are parallel, only one pair. So thus a trapezium looks like this generally. So ABCD. So here AB is parallel to CD. This will be called as a trapezium. So if one pair of opposite sides are parallel, then that quadrilateral is called as a trapezium. Now this quadrilateral has a certain properties. So what are the properties? Let me just share those properties and you will see its importance while solving the questions also today. So one of the property that we have here is pair of adjacent angles, right, which lie on the same side of the non-parallel side. For example, A and D, B and C are supplementary. So angle A plus angle D same as angle B plus angle C is 180 degree. That is one property. Right. Second property that we have in case of a trapezium is if you take a point which divides DA in the ratio m is to n, you take another point Q which divides CB in the ratio same m is to n, and if you join these 2 points you will get the line segment PQ. Now that PQ will be parallel to the parallel sides. That is one thing. Not just that, one more formula that we can note down here is the length of PQ line segment is nothing but m into AB plus n into CD upon m plus n. So if you know the ratio m and n, if you know length of the parallel sides, you can definitely calculate your own PQ. So if you know Mn, if you keep on changing M and N, the PQ will keep shifting up and down. You can find each of that length. Right. Now, third point that we have in a trapezium is, now instead of taking this points P and Q, instead let us say we join the opposite vertices. So basically I am asking you to draw the diagonal like this. So let us say the diagonals intersect at point P. So if you draw diagonals like this, one of the properties that we have is triangles PCD and triangles PAB. These two triangles are similar. When you join the diagonals, the two triangles which are opposite like this, they are similar. Not just that, the other pair of triangles you have, these two triangles, triangle PAD and triangle PBC. These two will be having equal areas. So area of this triangle will be equal to area of this triangle. This will happen in all types of trapezium, right? Smaller trapeziums, larger trapeziums, longer parallel side, longer this any type of trapezium you take, these 2 points will hold. Point number 5. Point number 5 is sum of the squares of the diagonals. Sum of the squares of the diagonals, we can directly calculate it as sum of the squares of the non-parallel sides plus twice product of the parallel sides. So if you want, we can also try to prove this here, right? But we'll not get into proofs and all because that would become too lengthy, right? We can just accept the results here. Sum of the squares of diagonals of a trapezium can be calculated like this. Sum of the squares of non-parallel plus twice the product of the parallel sides, right? Point number 6 that we have is in trapezium is area of a trapezium. Area of a trapezium is given as half into sum of the parallel sides into height of the trapezium, h, the distance between the parallel sides, this height. Okay, that's point number 6. Point number 7. So in case of trapezium, if this non-parallel sides become equal, then the trapezium will become isosceles trapezium. Just like isosceles triangle, it will become isosceles trapezium. Now in case of isosceles trapezium, there are some additional properties like diagonals are equal in length, opposite angles are supplementary, not just adjacent, opposite angles are supplementary. That means that sum is 180. So angle A plus angle C, angle B plus angle D is 180. This happens in case of isosceles trapezium. Base angles are equal. Base angle, just like your isosceles triangle, here also base angles will become equal. So these are some of the properties that I suggest we make a note of, right, from trapezium part. I am clearing this. Look at this question. Pause the screen right now. Based on whatever properties you have learned about trapezium, try out these questions. I, however, here in this session will be continuing with the discussion of this question. So it says in a trapezium AB is parallel to CD and AB is to CD is 2:5. So AB is a shorter length. So something like this. So this is your AB, this is CD. So this is 2 parts, this is 5 parts. The diagonals AC and BD intersect at E. What will be the ratio of areas of DAE, this triangle, and the area of the trapezium, the overall trapezium? What will be the ratio? So just now we have discussed some properties in trapezium, properties like, so the moment you draw these two diagonals, can I say this pair of triangles are similar? So can I say triangle EAB will be similar to triangle ECD? Order is very important, please note. How are they similar? Why are they similar? E is the vertically opposite angle, they will be equal, and angle A here will be equal to angle C here. Why? Alternate angles. Parallel lines cut by transversal, alternate angles are equal. So thus these two triangles are similar. If they are similar, can I say ratio of their sides? So what will be ratio of the sides? AB by CD, which is given to be as AB by CD, which is given to be as 2/5. Now also note, in case of similar triangles, not just the sides but perimeters also, heights also, radii also, everything will be in this ratio, 2:5 only. So that means, can I say height of the triangle, AEB by height of the triangle ECD will be equal to 2 by 5 only. So let us assume this height here to be as 2h and this height here as 5h. Let us assume it like this. Right? So if this is the case, what will be area of the trapezium? So area of the trapezium will be equal to what? Half sum of the parallel sides 2k plus 5k 7k into the height of the trapezium. What is height of the trapezium? 5h plus 2h 7h. So 7 into 7 49 by 2 24.5 k into h, or I can also write as 49 by 2. Let us keep it this way because he is asking us the ratio finally. So this is the area of the trapezium. I write it somewhere 49 by 2 k into h. I will just clean this. Next, what will be area of this triangle? AEB. So area of triangle AEB is nothing but half base into height, which is 2kh. What is area of triangle ECD? It's half base into height, which is 25 by 2, which is 12.5, 25 by 2 k into h. Now what is area of DAE? We don't know, let it be x. What is this? This will also be x. You remember one of the properties, these two triangles will have equal areas. Thus can I say total area? Will be equal to area of the trapezium. So when you solve this, this is 29 by 2, we will go on the other side. So 2x will be equal to 20 by 2, 10 kh, x will be equal to 5 kh. So this area x is 5 kh. He is asking you the ratio of this area DAE and area of the trapezium, hence my answer kh will cancel out. 2 when you multiply throughout, 5 into 2 is 10, 49. So thus the required area, the required ratio of the areas of the triangle DAE and that of the trapezium is going to be 10:49. Alright, I hope we are clear with this. Please make a note of this. Next is a question on parallelogram, but before we again take up this question, some properties of parallelogram. Now what do you mean by parallelogram? Parallelogram is basically a quadrilateral where opposite sides are parallel and equal. So if you take ABCD as the parallelogram, here opposite sides will be parallel and also equal. Similarly, BC will be parallel to the opposite side and also equal. Not just that, opposite angles are also equal. One more property is adjacent angles, any pair of adjacent angles, A with B, A with D, B with C, C with D, right, any pair, adjacent angles will be supplementary. Now here in case of parallelogram, if you take any point on the inside, if you connect this point with the vertices, sum of the areas of opposite triangles. So area of PAB plus area PCD will be equal to area PBC plus area PAD. They are going to be equal, right? So sum of these two will be equal to sum of these two. Each diagonal in the parallelogram divides the parallelogram into, each diagonal in the parallelogram divides it into two congruent triangles, identical triangles, right? I am not writing it down, but I am just orally saying it. Area of a parallelogram can be obtained as so many ways. Area, one of the formula is base into height. Height is the perpendicular height. This can also be product of two adjacent sides, say S1 and S2, into sine of include angle. This can also be written as half d1 d2. d1 and d2 are lengths of diagonals into sine alpha. So for example, if you take the parallelogram like this, these are the diagonals, let us say meet at alpha. So that alpha is at sine alpha, half d1 d2 sine. These are the various formulae that we have for finding out area of a parallelogram. One more point about parallelogram is sum of the squares of diagonals will be equal to, this will be equal to twice sum of the squares of adjacent sides. Okay. So this way we can find out lengths of the diagonals if one of the diagonals is given and the two sides of the parallelogram is given. So these are some properties that you may note down. Now we'll move on to the question at hand. Now have a look at this question, pause the screen, right? Try out this question and see if the answer matches with our discussion here or not. Let's try it out. Parallelogram ABCD, AB is 12. BC is 20 and AC, this diagonal, is 28. Find the area of the square with the side length equal to BD. So we know that area of the square is equal to side square. So if the square has a side length of BD, can I say its area will be BD square? So he is asking us to find out BD square is how much. So for finding BD square, we have the following equation, following property, the last thing that we discussed on the previous slide. AC square plus BD square is equal to twice AB square plus BC square. So what is AC square? AC is 28, so 28 square. BD square twice AB is 12. So when you simplify this 8, 28 square is 28 will be what? 1 second. 784 it is. Twice 12 square is 144. Plus 400. So this is 784. Twice this is 544. So when you simplify this, this is going to be 1088 minus 784 is going to be BD square. So BD square is 88 minus 84 is 04, 10 minus 7 is 3. Now BD square value is what we wanted to find out, because we wanted to find area of the square with side length BD, that is BD square is directly 304. So 304 directly, so whatever value we get is our answer. So there is no need of taking square or something, alright, square root or something, right. So BD square is what he asked for, BD square can be calculated this way. Okay, you can copy this. So with this we have come to the end of the session today, right. So today we have discussed quadrilaterals particularly. In the upcoming sessions I will be taking up other higher polygons, hexagon, octagon, etc. Right. I will also be taking up circles in the coming few classes. Right. So on that note, let me end the session here. Thank you and all the very best.